As per your syllabus, we need to see on what are these data structures in R. Like what you must be knowing, data structure is nothing but it's a particular way of organizing data in a computer so that it can be used effectively. And the idea is basically to reduce the space and time complexities of different tasks. This R's based data structure, they are often organized by their dimensionality. That is, it can be one dimension, two dimension, or n dimension. And even whether it is homogeneous or heterogeneous. Homogeneous means all elements must be of the identical type, and heterogeneous means the elements are of various types. And so all these things gives rise to six data types which are most frequently used in analysis of data. And the six types are vectors, list, data frame, matrices, arrays, and factors. Once again, it is vectors, lists, data frame, matrices, arrays, and factors. We will see everything using examples. Vector, the first one. It is what is a vector? It is an ordered collection of basic data types of a given length. And the only key thing here is that all the elements of a vector must be of identical data type. That is homogeneous data structure. Please remember, vectors are one dimensional data structures. Now, if I want to illustrate vector, like we know vectors are nothing but ordered collection of same data type. Let me take the variable x, which is the assignment variable. I shall say this is a combination of some numbers. I shall say 1, 3, 5, 7, 9. Now, when I call back this variable x, or for all of you who are comfortable with C, C sharp or anything where you say it is print of X, it is one and the same. It will list out all elements of the vector. Here the C stands for combination. That is, I am telling that the vector is an ordered collection of the same data type, which is all these numbers. And when I print out the vector or I call back this variable X, it gives me the same output. This is what is a vector.
This is an array, right?
This you're saying is an array. Array is slightly different. We are coming to that because array is another one more kind of data structure. This is a
Oh, I
vector.
see. Yeah. Yeah,
Yes,
okay.
madam. This
It
is a
has
vector.
arrays as well.
Yeah, it has even arrays. Vectors, once again, are one dimensional data structure, which we
Got it.
have taken an example.
Can you nest them to make them multi-dimensional?
We can make it two dimensional. Then it turns out from vectors to something else. It
Oh,
turns
that's
out to
cool.
be a data frame.
Oh, great. And does it do that transformation automatically? Is it
We
dynamically typed in that way?
No, there is a small function which needs to be used, which we will be seeing because
Okay,
data
cool.
frame is another data structure in R. The first
Great.
one which we have said is a vector, which is this one, which you can see in front of you. And all these are the ones which you will be using for solving problems. Okay. The third type of data structure is a data frame. See, these data frames, they are generic data objects in R, which are used to store the tabular data. And data frames, they are the foremost popular data objects in R programming. Why? Because we are comfortable in seeing the data in a tabular form. And we have been tuned to use Excel, where all the data is in rows and columns. So this data frame is very friendly to us. And please remember, These data frames are two-dimensional heterogeneous data structures, and they are a list of vectors of equal lengths. So what we shall do, we will create a data frame over here, maybe with the name. Let's have three columns. Let's say the name, language, and age. And these three columns will, let's have three entries to start off. So here, the first is I need to create a vector, which is a character vector, which I shall call it as name. Let me say the three names I take as Amaya. Let me say the second is Raj, and the third is Ashish. So this is a vector of three names. Then I create a vector for the next column, which is the language. So for me, let me say I need the language, which I shall say is the combination of, let me say R, uh, Python, and let me say Java. So this is for the language. And the third column, the first column we have name, the second language, and the third, let's have the age. So I take age as my variable, the combination of three ages. Let me say 22, 25, and 45. Now, to create a data frame, we need to use data.frame command, and then pass each of the vectors that we have created as arguments to this function data.frame. That is, let me take the variable as df. This will be data.frame. I need the name, I need the second column as language, and the third as age. Now, when I call back this variable df, wonderful data frame I get with three columns: name, language, and age. That's what we define. We get the same thing. You can create a data frame of whatever size you want. Here I just wanted maybe a 3 by 3 data frame. That's why we have created this.
Okay.
Okay. The second data structure is a list. What is a list? A list is a generic object consisting of an ordered collection of objects. And lists are heterogeneous data structures. They are also one dimensional data structure. But please remember, a list can be a list of vectors, a list can be a list of matrices, a list can be a list of characters, or it can be even a list of functions. Anything. Basically, list is a generic object consisting of an ordered collection of objects, which is nothing but it is an heterogeneous data structure. So to illustrate what is a list, let's say we create a small list of employee ID and employee name. So suppose I say the first attribute is a numeric vector containing the employee IDs, which is created, which we shall create using the C, the C for Charlie, which is the combination. That is, I say I have got employee ID, which is a combination of four numbers, 1, 2, 3, 4. So this forms my employee ID, which is the first attribute. Second attribute, let's say, is the employee name, which is created using one single line of code, which once again will be a combination. See, there are certain people who say that this C is a combination. Some people say it is a character vector. Whatever, it is both one and the same. Let's create the second attribute, which is employee name. I shall say employee name is the combination or the character of four names. Let me say Debbie, let me say Sandeep, let me say Shubham, and the last, let me say Shiba. The four names. So this is the second attribute. And let me create one more attribute, that is the number of employees. Since we have four employees, this will be a single numeric variable. That is, I shall say number of employee. This we know is 4. Now, here we can combine all these three different data types into a list which contains the details of employee, which can be done using a list command. That is, I shall say employee list, which I take as the variable. This is the list of the employee ID as well as employee name, as well as I need the number of employee. Oh, sorry, there is no space. Number of employee. Is there anything wrong in this number of? Oh, this sorry, there's a mistake. It is we are just given NUM. So num of employee. Now this basically, now if I want to print out this employee list, see what it says. It says it's the list of employee ID, which is 1234, employee name, these four employee names, and the number of employee. List basically is a combination of three different data types which we have taken here. You can say I can call back this variable, or I could have even told print employee list. It is exactly one and the same. However, okay, thank you. The next data type is what is a matrix. Like you know, a matrix is a rectangular arrangement of numbers in rows and columns. And in a matrix, as we know, rows are the ones that run horizontally and columns are the ones that run vertically. Matrices are two-dimensional homogeneous data structures. So we will see how do we create a matrix in R. To create a matrix, we use the matrix argument. That is, if I say I take the variable as A, this I would say I want it as a matrix, this consisting of a sequence of elements. What is the sequence of elements? I say it's the combination of some numbers from 1 to, let me say, 9. I take the combination of this. Apart from this, I also have to specify how many rows and how many columns. Since I have got 9 elements, let's take it as a matrix of 3 by 3. 3 rows, 3 column. So I say number of rows as 3 and number of column as 3. Now, after this, I need to specify how do I, in what order I want it, because by default matrices are in column wise order. So by specifying a parameter, that is, if I say by row equal to true, it will decide how to arrange the matrix. That is, I just say by row, this is true. This will tell it how to arrange the matrix here. Now, when I call back this variable A, I get my matrix. The next data type is an array. See, arrays are the R data objects which store the data in more than 2 dimensions. And arrays are nothing but n-dimensional data structures. Now, suppose we create an array of dimension, let me say 2 by 3 by 3. That means it will create 3 rectangular matrices, each with 2 rows and 3 columns. And arrays are homogeneous data structures. So we will see how do we create an array in R. Definitely, to create an array, I need to use the argument array. Once again, let me take the variable as A. I want an array of some sequence of elements. Let me say it is a combination of, let's say, numbers from 1 to 8. So I say 1 to 8. Apart from this, I want to create 2 rectangular matrices, each of them with 2 rows and 2 columns. So I shall say I want it with dimension, which will be a combination of 2 comma 2 comma 2. Now when I execute this and call this variable a here, I get two rectangular matrices, each of them with two rows and two columns. So the next data type is a factor. Factors are the data objects which are used to categorize the data and store it as levels. And they are used for storing categorical data. And they can store both strings and integers. And they are very useful to categorize unique values in columns like this true or false or male or female and such kind of things. And they are useful in data analysis for statistical modeling. So what we will do, we will see how to create factors in R. So when you want to create factors, I have to use the factor variable. That is, if I say I want to create a factor with a variable name fac, I have to say I need a factor of the combination of, let me say male, uh, female, let me again say male, then let me say I have a male, uh, female, male, and lastly let me say a female. So close and close. So now when I call back this variable fac, it tells me this is this and the levels are female and male. Once again, factors are nothing but they are data objects which are used to categorize the data and store it as levels. They are very useful, I said, in storing categorical data, and they can store both strings and integers.
So, sorry, quick question. These
Yes.
levels, these are just the distinct values of the set.
I'm sorry, sir. I didn't get you. Once again, could you tell me, please?
Yeah, how are these levels
Okay, okay. How are these
calculated?
levels? Yeah. See, I said, see, once again, these factors are useful to categorize unique values in columns. Here, the unique values are male and female. That's why it has told the level is female and male. That's all. How, why female first and male later? Alphabetic order. First F comes and then M comes.
Great, gotcha. Thank you.
That's it. Yeah. Okay, sir. So what
Makes
we,
sense.
okay, before, yeah, before I